I'm Chris Bryant, CCIE number 12933, and welcome to the third and final video in our series on floating static routes. I'll bring the diagram up here for just a moment and you can see where we are at this point in the lab. We've configured a static route over the 210.110/24 network because we've been told by the client that they want to use this network as a backup link for this router, router 1, to reach the Ethernet segment if the frame relay network goes down. Now we're running RIP version 2 over the frame relay circuit. That network number is 172.12.123.0 and the Ethernet segment 172.12.23.0. As mentioned, we're not running it over this particular link. So we configured a static route on router 1 using 210.113. This interface is the next hop. But the problem was when we put that in our routing table, the static route became the primary route and not any kind of backup link because of the administrative distance. The RIP route and the static route were both 172.12.23.0/27. Then the administrative distance becomes the tiebreaker. The lower the administrative distance, the more believable the source of the routes, and it doesn't get much lower than 1, but we do need to know that RIP's AD is 120. So now we're going to remove that static route and put on what we call a floating static route and see exactly how it's floating out there. So let's do a conf T here, and we can go through the last few commands we've run with the up arrow, and then I used Control A to move to the beginning of the line and just type in the word no. So we have successfully removed that, and now let's see if the RIP routes are back in the table that fast. That is pushing it with RIP. So let's clear the routing table with clear IP route asterisk. And now you can see the two RIP routes are back in the table as a result of removing that static route. So now we're going to put in a floating static route, which is simply a static route with an AD higher than that of the dynamic routing protocol in use. And in this case, of course, that's RIP. We know that's an AD of 120. And I'm going to use my up arrow because the command is just about the same as it is for a regular static route. You're still going to put your destination network, your mask, your next hop IP address, or your local router exit interface. But it's an option at the very end of the IP route command, illustrated here by iOS help, that lets us know how we can create a floating static route, and that's with this distance metric. That's referring to the AD of the route. So as long as it's higher than 120, in this particular case, we're going to be fine. So we'll just go ahead and put 122 for that. So a lot of numbers going straight across with no words in the middle here. So again, that's destination network, our network mask, our next hop IP address, and then finally the AD for this static route. This would not change the AD of any other static routes that happen to be in the table. It's only going to affect this particular route. So let's take a look at that routing table, and you can see that the RIP routes are still there. In the previous video, when we put the static route and didn't change the AD, those two RIP routes were removed immediately, or those two different RIP routes for the same destination were taken out of the table immediately. And here they were not. So what you could expect how you can expect this to look in your config is just like this. It will appear in the configuration, but it's not going to appear in your routing table unless the routes with the lower AD go away. And since this is a lab environment, we can do that, and we're going to close the serial 0 interface on router 1, which will cut off its RIP routes, and then we'll see if that floating static route then appears in the table. So we'll wait for the usual expected messages to come in, and there they are, administratively down, and line protocol is changed to down. And we'll do a quick show IP route. And you can see that the floating static route has successfully been placed into the routing table. Note that there is no special code for a floating static route. It's just the usual S, and that indicates a static route. It is not going to have an asterisk next to it because that is a floating static, a default static route if you saw an S and an asterisk, but you should not expect to see the asterisk as this is not any kind of default route. But you can also see the administrative distance is indeed 122. So that's why it's floating. It's kind of just floating out there until it's needed, and it was needed because those rip routes left the table. And let's go ahead and open that interface back up and see what happens. Let's make it serial 0 and see what happens. There's the line protocol coming up after we open up the physical interface. And let's check that routing table, and we'll do a quick clear IP route asterisk to force a RIP update. And should see him any second. I bet we see him on the next refresh. Still don't see it. Let's see how that goes. Okay, so RIP's running. We just haven't seen it yet. Let's force it one more time. And there we go. So every once in a while, especially with RIP, it just takes a few extra seconds, and we do get impatient in this business sometimes. But you can see that the RIP routes have been put back into the routing table because the update came in for the exact same network and network mask that we had the floating static route in the table for, and due to its lower administrative distance, these two routes were put back into the routing table. And of course, we have two routes to that destination because they have the exact same metric, and that's all. RIP performs equal cost load balancing by default. So that concludes our three-part look at floating static routes. Hope you enjoyed this series. For over 300 more Cisco and Microsoft tutorials, please visit our main website, www.thebryantadvantage.com/tutorials.htm. We've also launched a new certification website dedicated to Network Plus 2009 certification. You can find that at networkpluscertification.com. And I'm also excited to announce that our famous CCNA Mastermind webinar series is going on demand. So literally thousands of people around the world have wanted to attend this live course, and they haven't been able to because of time zone issues. And now everyone will be able to attend when you're ready because the webinar will be on demand. It's going to be on your schedule whenever you're ready. And I'd ask you to visit the website, thebryantadvantage.com, and visit the blog and sign up for the daily newsletter, which brings you daily exam questions, practice exam questions, to your inbox, and you'll also be the first to know about all the details about the on-demand webinar. Thanks again for watching today's video. I'm Chris Bryant, CCIE number 12933. Thanks for watching.